Okay, a few examples of a f of x minus h plus k equals a number. Just following up on the review exercises that we did in class. So if we have instead of a f of x minus h plus k equals d or whatever, we got numbers here. Instead of a, we've got 5. Instead of h, we got 3. Instead of k, we've got 9. Instead of d, we've got 13. So this is just an a f of x plus h, a f of x minus h plus k. So here it is. And of course, the function is the toolkit exponential function. Okay, how do we solve this? Well, we want to get to x. But x is up here in the exponent, and we don't have a good way to get to that until we clear out a bunch of other stuff. So what we want to do is we want to isolate the 2 to the x minus 3. How do we do that? Well, we've got a plus 9 here. We can subtract 9 from both sides, get rid of that. And then we're going to end up with 5 times 2 to the x minus 3 equals 4. Well, the 5 is easy to get rid of. We're multiplying the 2 to the x minus 3 by 5. We divide both sides by 5. And we end up then with 2 to the x minus 3 equals 4/5. Then we just convert this to log form. X minus 3 is log base 2 of 4/5. Add 3 to both sides, and there's x. Okay. Now, very similar in this case. We're trying to find x. Of course, x is confined to this expression, x minus 3 quantity squared. Now, we do have another alternative here, but it's not the one I'm going to use. We could use a binomial expansion, or we could just use a distributive law and expand the x minus 3 and collect all our terms and get an ax squared plus bx plus c equals 0 and apply the quadratic formula, and that'd be perfectly valid. It's actually easier just to get rid of that 9 the same way we did over here. We subtract it from both sides. And then we divide both sides by 5, and we end up with x minus 3 quantity squared. And that's going to be equal to 4/5. Just like we got 2 to the x minus 3 equals 4/5. Now, in this case, we've had to convert to logarithmic form because that's how you solve an exponential equation. In this case, we have a square equal to 4/5. Well, if something squared equals 4/5, then that thing is either plus or minus the square root of 4/5, because of course, if we square plus the square root of 4/5, we're going to get 4/5. If we square minus square root of 4/5, the minus times the minus is going to give us a plus. We're still going to get 4/5. Okay, so we get x minus 3 equals plus or minus 4/5. Well, we add 3 to both sides. We get x minus 3. Well, we add 3 to both sides, get rid of the 3. We get x equals 3 plus or minus the square root of 4/5. Our solution set, if we want to write it out, would be 3 plus square root of 4/5. It might be a little hard to read. So it's kind of slipping there. 3 minus the square root of 4/5. We would generally present the solution as a set of 2 possible solutions to the equation. Okay, and of course, the square root of 4/5 could be simplified to 2 over the square root of 5, and you might make sure that you know how to do that. Okay. And here we have a square root. Our toolkit function is a square root function. So our a f of x minus h plus k equals d function, that's equation, is this. You're probably getting used to this. We subtract the 9 from both sides, and then we divide both sides by 9, and we get the square of x minus 3 equals 4/5. Okay, just very much like what we had here, except this is a square root. And what do we do with that? We square both sides. If you square the square root, you just get the quantity under the square root, because what is the square root of a quantity? It's the thing you square to get that quantity. Make sure you understand that. Okay, so You don't just memorize, well, I square that, and that's what I get. Make sure you understand it in terms of the definition of the square root. In any case, when we square the square root of x minus 3, we get x minus 3. The square of 4/5 is 16/25. We understand fractions. Okay, then we add 3 to both sides, as we've always done, and we get x equals 16/25 plus 3. Now, I write that and skip a step here, or combine two steps. Okay, I've got 3. And instead of writing 3, I write it as 3 over 1 times 25 over 25, because to add these, one common denominator. And that's going to give me, well, 3 times 25 is 75. So we're going to have 16 plus 75 all over the denominator 25. It gives us 91 over 25. And I want to see the fractions. I don't want to see a bunch of decimal approximations. I want to see the actual numbers. In this case, decimal approximation is fairly straightforward. Okay, I think it's 3.64, I think. So you can check that out. Maybe I got that, maybe I didn't. Okay, in the case of the reciprocal function, the toolkit reciprocal function, your a f of x minus h plus k is 5 over x minus 3 plus 9. And that's equal to your d, what I choose to call d. To solve this equation, we see that x minus 3 is in the denominator, so we multiply both sides by that denominator. We always want to clear denominators. Now, you could subtract the 9 from both sides before multiplying both sides by the denominator. That would actually be more efficient. But I'm emphasizing the idea that we want to multiply by the denominator, and it doesn't hurt to do it as quickly as possible. Okay, so we do that, and x minus 3 over 1 times 5 over x minus 3 just gives us 5. Okay, because the x minus 3 over x minus 3 is 1. We've already got a 1 there. So we get 5. And then we have 9 times the quantity x minus 3. X minus 3 over 1 times 9 is just x minus 3 times 9, or 9 times quantity x minus 3. On the right-hand side, x minus 3 times 13 gives us 13x minus 39. Then we use the distributive law here. And 9 times quantity x minus 3 is 9x minus 27. We add the 9 and the negative 27. Oh, yeah, it's 9x. A minute I've seen that as a multiplication sign. I'm not with it here. Okay, 9x minus 22 equals this. And then that's very straightforward. We subtract 13x from both sides. We get negative 4x over here. We add 22 to both sides. We get negative 17 over here. And then divide both sides by negative 4. We get x equals 17 over 4. We should understand all those steps, all those details. One last comment. All these are a f of x minus h plus k equals d, with a equals 5, h equals 3, a equals 9, d equals 13. We've done this for the toolkit exponential, toolkit squaring, toolkit square root, and toolkit reciprocal function. And of course, this is something you're going to need to be able to do in the exam.